measurement of conductivity of ionic solution. Ionic solution. How to measure the conductivity or specific conductance in ionic solutions? Okay, here unknown resistance can be calculated by using a Wheatstone bridge. We don't know how to calculate the resistance of unknown resistance. How to calculate the unknown resistance by using a Wheatstone bridge. Okay, the resistance of ionic solution is measured by using of AC. AC means alternative current source of power, and a specially designed vessel is called conductivity cell. Okay, unknown resistance can be calculated by using of Wheatstone bridge. Unknown resistance can be calculated by using of Wheatstone bridge. The resistance of ionic solution is measured by AC, alternate current source of power, and it is specially designed vessel that is called conductivity cell. The conductivity cells consist of two platinum electrodes coated with platinum black, whose area of cross section and are separated by distance L. The resistance of solution determined by the equation. Okay, how to determine the resistance of the equation? R is equal to rho into L by A. That means here the area of cross section A, distance between the two electrodes L. This resistance is directly proportional to the length of the electrodes or distance between the two parallel electrodes and the area of cross section. The quantity of L by A, already you know, it is a cell constant. This is cell constant. It is denoted by symbol G star. It is depending upon some factors. That is called distance between the electrode. The first factor is distance between two electrodes, and second one is area of cross section, and third one is here there are two points here, distance between the two electrodes and area of cross section. The cell constant determined by using of resistance of all cell containing a solution whose conductivity is already known. You can observe here. Now I am taking a diagram. Which is connected to the oscillation here. R1, R2, R3. For example, this is R1 resistance 1, resistance 2, resistance 3 and resistance 4, which is connected to the detector. It is a detector, but this is the unknown here. In this unknown resistance, How to measure? In this unknown resistance, R2 can be calculated as a R2 is equal to R1 into R3 by R4 is the formula. This is opposite here. These two are multiplying. R1 into R4 by R3. Opposite to multiplying these two, R1 into R4, R2 is equal to R3. Actually, this is the formula. R2, R3 is equal to R1 into R4. Now I want unknown resistance R1, R4 by R3. To calculate the unknown resistance by using a Wheatstone bridge, okay, instead of AC, we can use DC. Leads to the electrolysis result in the change of concentration, polarization at the electrode resulting change in its resistance. This is how to measurements of the conductivity of ionic solutions. Now we will discuss molar conductance. Molar conductance. It is denoted by symbol lambda m. Distance between two, area of cross section here. You can observe here. What is the definition here, sir? The conducting power of all the ions produced by dissolving 1 gram mole of electron. The conducting power of all the ions. The conducting power of all the ions produced by or dissociation or ionization by dissociated or produced or ionized by 1 gram mole of produced by dissolving 1 gram mole, that means 1 gram molecular weight, 1 gram mole of an electrolyte is called molar conductance. It is denoted by symbol lambda m, or the conductance of volume of the solution containing, or one more definition, the conductance of volume of the solution containing 1 gram molecular weight of the electrolyte placed between two electrodes and separated by distance unit length 1 centimeter or 1 meter is called molar conductance. The conductance of a volume of solution containing, this is 1 mole. The conductance of volume of a solution, this is the volume of solution, entire solution, this is the volume. The conductance of a volume of a solution containing 1 gram molecular weight of electrolyte placed between 1 gram molecular weight of electrolyte placed between two parallel electrodes separated by distance 1 unit length, that is unit length of 1 centimeter or 1 meter is called molar conductance. Or one more definition here, the conductance of all the ions in that volume of solution in which 1 mole of electrolyte is present. 1 mole of electrolyte, so all the ions can be produced dissolving on 1 gram mole of electrolyte. It is also called molar conductance. Okay, the mathematical formula of this one, lambda m is equal to K into volume in liter. Actually, volume, now I am taking molality is equal to number of moles of solute dissolved per volume in liter. If you take volume in this side in liter, N by M. In case now I am taking volume in cubic centimeter, 1 mole into 1000. That means here K into 1000 by M is the mathematical formula of molar conductance, where M is a molarity, the number of moles of solute dissolved for 1 liter of the solution, where K is a specific conductance. What are the units of this molar conductance? That is equal to, what is the units of K? Siemen centimeter inverse into volume is equal to centimeter cube per liter by molarity moles per liter moles per liter. That means Siemen centimeter square per mole. Finally, what are the units here of molar conductance? Siemen centimeter square mole inverse. In case if you take SI units, instead of Siemen ohm inverse, meter square mole inverse, SI units, or S meter square mole inverse. Okay, this is information about molar conductance. Another one is equivalent conductance. Equivalent conductance is denoted by symbol lambda EQ. It is defined as the conducting power of all the ions produced by dissolving of 1 gram equivalent of an electrolyte. The conducting power of all the ions produced by dissolving 1 gram equivalent weight, 1 gram equivalent of an electrolyte is called equivalent conductance, or the conductance volume of a solution containing 1 gram equivalent of the electrolyte placed between the two parallel electrodes separated by unit length 1 centimeter is also called equivalent conductance. Here also same formula. Lambda EQ is equal to K into volume in liter. If you take volume, normality is equal to N by volume in liter. If you take volume in cc, 1 by N into 1000. K into 1000 by N. This is the formula. Here what are the units? Same units, but little bit difference here. Siemens centimeter square per mole place here for equivalent. Equivalent inverse or ohm inverse centimeter square equivalent 4 minus 1 inverse. Relation between molar conductance and equivalent conductance. Molar conductance and equivalent conductance. Okay, what is the formula of molar conductance here? K into 1000 by N, equation 1. Molar conductance K into 1000 by M. Divide equation 1 by 2. Now what happened? That is lambda EQ by lambda M. K into 1000 by N into M by K into 1000 gets cancelled, K gets cancelled here, M by N. That is equal to 1 by charge of cation or anion, charge on cations, charge on cation or anion. Simply lambda EQ by lambda M is equal to, what is the molality? Weight by gram molecular weight. Here gram equivalent weight by weight. That is equal to lambda EQ is equal to lambda M, gram equivalent weight by gram molecular weight. Therefore lambda EQ is equal to lambda M into by using of cross multiplication here, lambda M is equal to lambda EQ into charge on cation or anions. This is the relation between lambda M and, that is molar conductance and equivalent conductance. Thank you.